before we get started, why are we doing this? What's the point of georeferencing? And I'd like to show you one reason why it's kind of nice by showing you a hard way to do what we'll eventually be doing here. Now in Google Earth Pro or Google Earth Normal, you've got this key right here, this button, and if you hover over it, it says Add Image Overlay. So this is the hard way to do this. You can click on that, browse, and locate any map, actually any image that you want. Now this particular one happens to be for somewhere in this area. It's still loading, there it goes. So I'll just move this out of the way here. You can place this in Google Earth by resizing it, by grabbing the corners. You can squish and move it. You can rotate it from here. Grabbing the center will allow you to move it. And believe it or not, this is actually how Google tells you to do it if you don't have Pro. So lightening it sometimes helps, sometimes not. And you can imagine how easy this is and how fun it is. So you can spend a lot of time getting this thing to line up. And even if you are successful, all you've done is created something that's only usable in Google Earth. It's kind of a one-way street. So we want to georeference an image so we can use it in Google Earth as well as the Avenza software and ArcGIS and any number of GIS applications. So with this particular overlay, I'll just hit cancel because we don't want that, and let's move this out of the way. That particular image that I just showed you, it's actually the same thing as this, a slightly modified version, but something very important with file sizes that you should know. If I do a get info on this image, I can see the actual file size is only 3.9 megabytes. And in the assignment, I've given you a range to try to keep this in. We don't want it too large, but we also want it large enough where it's not just a web graphic. But you have to be very aware of an actual file size and the actual uncompressed size. This is a very compressed image. It only clocks in at 3.9 megabytes. But if we were to open this with Photoshop, you can see from the corner here that uncompressed, it's very, very large. Now, you can georeference any of these images, and if you really need to retain that resolution, you might as well keep it that high. But for this assignment, and I don't want to be crashing Blackboard, try to get that down. I think I said between 2 and 10, but actually if you keep it between 2 and 20 megabytes, you'll be fine. So what I'd recommend is if you open an image and you see that it's that large, click on image, go to image size, and I like to change the percent height and width just to get that number down. So if I try 20%, I can probably go a little bit higher, 30, that's reasonable. And again, I'm just doing this and recommending this. It'll speed up the exercise, and it'll give you a file that you can actually upload to Blackboard. Now this particular graphic is it's something I just found online, but it works very well for a pseudo Mercator projection that we want to use in this exercise. There's a few conditions that you have to meet. One is you need to know where the image actually is in the real world, and I was able to find out because I think, it says County of Santa Cruz, and I just zoomed in. It's pretty easy to locate. The other thing is you need some sort of real world reference to align this. And whenever you see a base map like this, it's usually something created from a civil engineering survey, and they're usually pretty accurate. So you need to be able to identify reference points, or in this exercise we're calling them ground control points. And things that work very nice are intersections of roads. They usually don't change. Property lines sometimes work very well because oftentimes there's a fence right at the property line, so that point would work okay. Sometimes if you have to, you can use structures, but I don't recommend it just because things that are closer to the ground in hardscapes generally work better. Definitely not vegetation. That's usually not that accurate. The other condition, I guess, that's mentioned in the tutorial is that north needs to be pointing up. And you actually don't have to have that because there's a step we do that will automatically rotate your image. So if you have something that's a little crooked like that, that's fine. The one thing I'd recommend is in Google Earth, when we get to the step where we are finding the actual longitude and latitude, it's a little bit easier to align your map to the same north direction. And you can do that by clicking on this little navigation N up here. And that N is kind of pointing in that direction. So if I zoom out, you can start to see the maps line up a little bit better. So I think that map covers an area about in this general location. So if you have a map, something like this from a previous studio or any other class project or a real world project, it'll work very well. But if you don't, that is fine. I'll show you how you can find one pretty easily. And what I'll do is go to images.google.com. Now, you could just search for map or plan or site, but what I found works well is throw in some kind of combination of proposed site plan. And you'll get some fun color ones to work with. That'll probably work very well. You could do conceptual site plan, or you could try conceptual master plan. The one other thing to kind of weed out some of the smaller images is over on the left hand side here, click on larger than, and let's go larger than 2 megabytes or megapixels or whatever that stands for, I guess. We can always make it smaller, but if you find a really low resolution image, it's not going to do you any good. So play around, throw in some nouns up here like hospital. And I fully expect everyone to have a unique map. There's enough options out there where nobody should have the same image. We could do campus. So just be creative, find something that looks interesting to you, to Georeference, and make sure it meets those other requirements. It's a pseudo Mercator. You can find it on the real world, and you've got some reference ground control points to choose from. Now another thing you could search for instead of a noun like campus or hospital is toss in an adjective like rejected site plan. It's also kind of fun to see what might have been. So let's see this one. Let's see what this one's all about. So I believe this is Los Angeles. And to actually see the real image, the real full-size image, you'll want to click on this full-size image over here. And then right-click on that image and select Save Image As. So I'll just call this LA, and I think I'll add the JPEG extension just so my computer knows what kind of file it is. So here is my image. Let's see. If you zoom in, you can get an idea. Yeah, so it is LA of where it is. And hopefully, this is a really good one too because, I can find Hope Street and 3rd Street pretty easily, as well as some of these others. So what I'll do, let's go back to Google Earth. Now, the reason we're using Google Earth is to find the real world coordinates, the longitude and latitude in decimal degrees. I showed a few ways you could do this in class, but Google Earth, the free version can do this as well as the pro version. All you need to do is click on the place mark, keep an eye on these numbers here. As I drag that place mark around, you see them change. So we're only using it for this purpose, just to find that point, cut and paste these numbers when we apply the georeferencing tool. So let me just cancel this. I'll do a search for Los Angeles. Now, if you're not quite sure where it's at, sometimes you can search for street intersections. If they're unique enough, for example, how many Hill Streets and Temple Streets are there in the country? Now, this only works for United States addresses. You can't do this, at least, I don't believe you can do it with other countries, but you know what? Let's just try it and see what happens. So if I do Hill Street and Temple Street, hit search. It's zooming me right in. So when we're first finding these ground control points, let's turn off all of the Google Earth layers. And that can be done over here. There's a lot of different layers of geo information that can be superimposed on the Google Earth map. Clicking that top primary database so nothing is selected makes it much easier to work with. Back on this map, it doesn't look like north is pointing quite up. So I can see from this little graphic north is kind of off to the side. Back in Google Earth, what I'll do is try to match that up. It'll just make this a lot easier. And there I can see there's this courtyard area. Zoom out just a little bit, and I'll get rid of this. So at this point, we're ready to find the ground control points, which we need to georeference this image.